Dear students, this is your professor Edwin in the second part of our first unit. So we will do some problems that what we have seen in our standard cycles. Before going to that, I wanted to recollect what we have learned earlier. The nomenclatures of ICE engines, you always keep it in mind. The stroke length, that is the length of stroke, and the diameter of the piston. These two things you keep it in mind so that we can calculate the swept volume. This diagram, I think you can see that this colored portion as the piston moves from TDC to BDC or from BDC to TDC, the volume swept by the piston is called as our swept volume or displacement volume, which we calculate in as pi by 4 d square, that is the cross-section area of the piston into the length of stroke will give that volume. And always remember that the second term, that is the clearance volume, the volume which is left when the piston has reached the top dead center. Okay, this is the entire cycle, we know that, which we have dealt in our previous lecture. So I'm not going to hang on there. Just you can, this is very important. This is the portion I want you to keep it in mind at the fingertip. You should always have. If anytime if it is asked Otto cycle, diesel cycle and dual cycle, you should be able to draw at least the PV diagram. Of course, it is better to know the TS diagram as well, but at least you should remember the PV diagram. The difference is, I think you know that Otto cycle is constant volume cycle. Only variation you can see it in the heat addition. Constant volume cycle, this V2 equal to V3. It's a vertical line in a PV diagram. Heat addition is at constant volume. When it comes to diesel, which is otherwise called as constant pressure cycle, because the heat addition is at constant pressure, you can see that P2 is equal to P3. Not the volume is not constant here. Volume changes from V2 to V3, but the pressure remains constant at P2 equal to P3. The better approximation is, of course, you know that it is a dual cycle. In the dual cycle, you can see the heat addition is a combination of constant volume and constant pressure. You can see that 2 to 3 is constant volume because V2 is equal to V3, and then from 3 to 4 it is constant pressure. The pressure remains constant. Here in this case we say P3 is equal to P4. This diagram is very important as far as this unit is concerned to solve problems. You should be able to draw, then only you can take the given data correctly. Auto, diesel and dual. Okay, coming to the problem. Today I would like to do 4 problems. Okay, exactly 3 big problems, one each for each cycle. So first one, let us take it as an Otto cycle. Otto cycle, you know that it's a constant volume cycle. So heat addition is at constant volume. That should be in your mind. Immediately you draw the diagram. Then we can take one by one the given data. If it is in the given data, you know that first I think you should understand that it is an Otto cycle. It's an Otto cycle because first line says it's an ideal Otto cycle. Constant volume cycle. Then you have to be careful with that. What else is given? Compression ratio is given. Think about the compression process. It is starting from 1 to 2 is compression. 1 to 2 is compression. So always you remember higher volume will come at the top. So it is V1 by V2. Process is 1 to 2 is compression. Higher volume will come at the top. There is a basic thumb rule. So it is V1 by V2 is given as V8. Sorry, it is 8. Then you can understand in the problem beginning of compression process. So beginning of compression is 0.1. So they have given the pressure as 100 kilopascal. 1 pascal is 1 Newton per meter square. So kilopascal means kilonewton per meter square. So it is very easy. In the given data itself, you better write it in the proper unit. 100 kilonewton per meter square. Of course, the temperature is given. Temperature is given in degree centigrade. always you make it into Kelvin. Plus 273, you will get it as 290 Kelvin. Then one more data you have to be very careful, and they have given 180 kilojoule per kilogram of heat is transferred to air. Heat addition, Q1, we will say, in 2 to 3, heat addition, that is given data. So Q1, how will you calculate? It is a constant volume process, so always remember it is CV, because it is mass into specific heat into change in temperature. So 2 to 3 is the heat addition, always higher temperature minus lower temperature, so it is T3 minus T2. So what is, either it is CP or CV, that confusion you will be having. It's constant volume, so it is CV, specific heat at constant volume. So that is given as, it's a given data, 800 kilojoule per kilogram. When they say it is per kilogram, that implies mass is 1 kilogram. That is also given data, we should take it accordingly. So let us try to solve this problem, okay? And it's an air standard cycle, so you should, and it is given air. For air, you know the properties, CV is, you should know all these 3 values. Ratio of specific heat, gamma is 1.4, CP is 1.005 kilojoule per kilogram Kelvin, and CV is 0.718 kilojoule per kilogram Kelvin. These are very, very important things you should know. You should by heart it. And gamma is 1.4. Let us try to find out all the temperatures. Because once the temperature is known, you can calculate efficiency, work net, and all other things immediately. Okay, we'll go ahead. Okay, T1 is given so that you can calculate T2. Here again, let us take the process 1 to 2. What is the 1 to 2 process? It is a reversible adiabatic, otherwise called as isentropic. So you can apply that law. You have an equation, T2 by T1 is equal to P2 by P1 to the power gamma minus 1 by gamma. That is equal to V1 by V2. So you can see that temperature and volume means it's a reciprocal. T2 comes at the top, so here V1 comes at the top. When it is a relationship between temperature and volume, you could understand that is a reciprocal is there. So you have to be very careful in memorizing. So T2 by T1 equal to V1 by V2 to the power gamma minus 1. So from that you can calculate V1 by V2 is compression ratio 8. So T2 is equal to T1 into 8 to the power of 1 minus 1.4 minus 1, that is 0.4. So that will give you the value of T2 as 666.25, but you can do the calculations. Once that is known, we can move on to the temperature 3. You understand that they have given the heat addition Q1, that is MCV T3 minus T2. Apart from T3, all other values are known values. Only T3 is unknown, so you can directly calculate the value of T3. Then let us move to T4. T4 again, you remember what is the process 3 to 4? Process 3 to 4 is reversible adiabatic, so you can use this law. So T4 by T3, because you have to calculate T4, that is why I am writing T4 at the top. So when I write T4 at the top, V3 will come at the top. That you should be careful about it. So T4 by T3 is equal to V3 by V4 to the power gamma minus 1. You note it. V3 is equal to V2. Both are same. Isn't it? It's a constant volume process, 2 to 3. So instead of V3, we can put it as V2. Instead of V4, you can put it as V1. So it is V2 by V1. V1 by V2 is 8. So V2 by V1 is 1 by 8. So directly you can calculate the temperature T4. Now you know all the temperatures. T1 is given, isn't it? 290 Kelvin. T2 is known. T3 is known. T4 is you have found out. So once all the temperature has been found out, then it's very easy. So for example, okay, you need to, because they have asked the work net and they have asked the mean effective pressure, we need to calculate V1 and V2. So V1, how to calculate V1, which is not given. They are given V1 by V2 only as 8, that's the compression ratio. This basic equation always remains PV equal to MRT. That is a basic equation, you know that. R is equal to 0.287 kilojoule per kilogram Kelvin. M is equal to 1, T1 is 290, P1 is given, isn't it? P1 is given as 100 kilonewton per meter square. Just apply it, you can get the exact value of V1. So V1 is found out. So V1 by V2 is equal to 8. So you can calculate V2 also. V2 is V1 by 8. So you'll get both the values of V1 and V2. Then you can still move on to find out P2. You can find out the temperature of P2. So 1 to 2 is PV to the power gamma equal to constant. That means P1 V1 to the power gamma equal to P2 V2 to the power gamma. So that is your basic equation, isentropic equation. From that you can calculate P2 and you can straight away calculate the value of P2 because V1 by V2 is 8. So you can calculate the value of P2 from there. Once P2 is known, we are all applying the basic laws. 2 to 3 is a process. Of course, it's a constant volume process. For all process, PV by T equal to constant. So PV by T is a constant. We are applying it for process 2 to 3. Here you know that V2 is equal to V3. So you can cancel it. Then only unknown in this equation becomes P3, and you can calculate the value of P3 because they have asked maximum temperature. What is the maximum temperature is the first question. Maximum temperature and pressure. So you know the maximum temperature is T3, but we have already calculated, and the maximum pressure is P3. And once the temperature is known, other things, the formulas remains the same. The net work output, we know that it is expansion minus compression. Cyclic work transfer equal to cyclic heat transfer. We always apply the basic thermodynamics law. That is Q1 minus Q2. Q1 is already, we have, it's a given data, 800. So Q2 you have to calculate. Q2 is, let us take the process. So 421 is constant volume process. So once it is a constant volume process, MCV comes, CV comes. MCV T4 minus T1. So all other things are known value. You can calculate the value of Q2. Q1 minus 2 is work net that you can find out. Then the thermal efficiency is always output by input. If it is an engine, output is work net, work, mechanical work, shaft work is the output, and Q1 is heat input. So that gives us work net equal to Q1 minus Q2 by heat input. So you'll get the efficiency as this much. And you know the formula for mean effective pressures. Work net equal to mean effective pressure into swept volume. So that mean effective pressure equal to work net by V1 minus V2. That is why we have calculated the value of V1 and V2. So simply you get it in kilopascal or kilonewton per meter square, because 1 pascal is 1 newton per meter square. So you can either say it is a kilopascal or a kilonewton per meter square. This is a similar a typical example for an Otto cycle. You can go through a lot of exercise problems in the textbooks also, but this is one simple problem. Okay. Let us move to diesel cycle. This is one typically it is asked, university repeatedly asked, but it is very simple. You can see that problem itself is very small, but you should be able to understand. But here to solve the problem, you need to memorize the basic equation for efficiency. Okay, whatever may be. When it comes to diesel, the word diesel engine comes, when a diesel comes, you should be able to draw this diagram. Variation is 2 to 3 is constant pressure. Constant pressure, P2 is equal to P3. So that is your basic understanding is very important. There Otto cycle is volume is constant, here it is pressure is constant. Let us go into the given data. They have given compression ratio, so process 1 to 2 is compression. Higher volume will come at the top. So you know that V1 by V2 is, of course it is a diesel, compression ratio V1 by V2 is given as 18. Then you have to be very careful. Then they say cutoff takes place The hidden thing is cutoff volume. That's an understanding you should have. Cutoff volume. What is cutoff volume? What is the process the cutoff means? Fuel injection starts and ends. That period we call it as a cutoff period. Fuel injection period is called as cutoff period. So fuel injection starts at 2 and ends at 3. So 2 to 3 is your cutoff volume. So cutoff volume is V3 minus V2. V3 minus V2. That is the volume. So that volume is 5% of stroke. They put it as stroke. Don't think it is a stroke length. That is a word which is very used, but context-wise you should understand the meaning of it. So here it's a cutoff volume is 5% of stroke volume. That is the meaning here. Okay. So what is cutoff volume? V3 minus V2 is equal to 5%. That is 5 by 100 of swept volume. Volume swept by the piston. Volume swept by the piston, or stroke volume. That is a different word. Stroke volume, swept volume. Okay. Displacement volume. The different word they use it. And only these two data are given, and for air it is gamma equal to 1.4, and you have to take air standard efficiency. So let us take that way. V1 by V2 equal to 18. So V1 you can write it in terms of V2 as 18 V2, just cross multiplication here. That's a cross multiplication here. And now let us put what is stroke volume. What is stroke volume? Stroke volume is because it moves from V1 to V2. V1 to V2 is a stroke volume. So V1 minus V2 is stroke volume. Okay, V1 minus V2 is stroke volume. So instead of V1, we are putting it as 18 V2 because that is how we have calculated. So 18 minus 1 V2 will give us 17 V2. So just a simplification. Then let us take as cutoff volume. Cutoff volume is V3 minus V2. So here now we are introducing instead of that is given as V3 minus V2 is given as 0.5 of Vs, isn't it? That is a given data, 0.5 of Vs. So this Vs is equal to it is 17 V2, is it not? That we have taken as 17 V2. Vs is equal to 17 V2. So 0.05 into 17 V2 is equal to 0.85 V2. So you are getting V3 minus V2 is equal to 0.85 V2. So what is V3? What is V3? So V3 is, you can just change it. So V2 plus 0.85 V2, that is equal to 1.85 V2. So V3 you are getting it as in terms of 1.85 into V2. So V3 by V2. What is V3? It's a ratio. That is called as cutoff ratio. Cutoff volume is V3 minus V2. Cutoff ratio is V3 by V2. So cutoff fuel injection, that process is 2 to 3. When it comes to ratio, higher will come at the top. That is why V3 comes at the top. V3 is higher volume. V3 comes at the top. V3 by V2, just to remember that way. So you can see that cutoff ratio, you will get it as 1.85. Now you have compression ratio is known, cutoff ratio is known, and you have the formula to calculate the efficiency. Once you know the cutoff ratios and other things, this is an equation. You will get it after derivations. This you have to remember. Easy to remember is this is Otto cycle, 1 minus 1 by Rk to the power gamma minus 1. Rk is compression ratio, Rc is cutoff ratio, and gamma is ratio of specific heat, that is 1.4. So once you apply it in this equation, you will get the efficiency. This is a simple problem which comes in diesel. I wanted to do two more problems. You can take a break in listening. You work out side by side. You can pause and you can work out. Okay. Dear friends, I hope you understand it. I hope you will listen. I hope you will learn. Hope you will work out more problem that will give some result. Okay. So let us take another problem in diesel. So engine works on diesel cycle. That is the way first you should take. It works on diesel cycle. So cycle is diesel, constant pressure. So they have given inlet pressure, temperature. Inlet is 0.1, isn't it? So you know that it is P1 is given as 1 bar. 1 bar is 10 to the power of 5 Newton per meter square, or 10 to the power of 2 kilonewton per meter square. Unit conversion is very, very important. If you miss it, everything is gone. And the temperature is given as, of course, 17 degrees centigrade plus 273, you will get it as 290 as T1. Then they have given pressure at the end of adiabatic compression. End of adiabatic compression. So 1 to 2 is compression. End of adiabatic compression is P2. P2 is given as 35 bar. 35 bar is 35 Newton to the power of 2 Newton per meter square. And you know that P2 is equal to P3. So P3 is also given. Because it's a constant pressure heat addition, P2 is equal to P3. Even though it is not given, that implies P2 equal to P3. Then one more is also given. The ratio of expansion. The ratio of expansion, or in another way, it's an expansion ratio. Expansion ratio. What is the process of expansion here? 3 to 4 is expansion. Expansion in the cylinder. So when it comes to ratio, higher volume will come at the top. That is a thumb rule for us. 3 to 4 is expansion. So you know that V4 is the highest volume compared with V3. So expansion ratio is always V4 by V3 is given as 5. Is given as 5. So given data is very, very important. Then they are asking you to calculate heat addition, heat rejection, and efficiency. Again, the best rule is calculate all the 4 temperatures. One is given, T1 is given. That is calculate T2, T3, and T4. Then things will be. Okay, T1 is given as 70 degrees centigrade. So it is 290 Kelvin. And let us take T2. T2, they have not given the compression ratio is not given, but they have given the pressure P1 and P2. So we are trying to use the other equation for adiabatic process, reversible adiabatic process. T2 by T1 is equal to P2 by P1 to the power gamma minus 1 by gamma. So this equation only unknown is T2. So that T2 can be found out easily. So once T2 is found out, you know that P2 equal to P3. P2 is equal to P3. So that P3 is also known. And you know that V4 is equal to V1. So let us try to use this equation. 3 to 4, process 3 to 4. Process 3 to 4 is nothing but it's an adiabatic process which follows the law PV to the power n equal to constant, PV to the power gamma equals to constant adiabatic. So you take the basic equation is P3 V3 to the power gamma equal to P4 V4 to the power gamma. From this you can understand, you can rewrite it as, because only unknown is P4, because P3 is equal to P2, so known. V3 because they have given expansion ratio, that is V4 by V3 is given as 5. This 5 is V4 by V3. So V3 by V4 is 1 by 5. So all other data are known, you can calculate the value of P4. Why we calculate P4? But we have to come again. Because now let us come to T4. Okay, P4 is known. So let us take the process 4 to 1 now. 4 to 1 is a process in which we are applying P4 V4 by T4 equal to P1 V1 by T1. You know that V4 is equal to V1. So that you can cancel it. If you cancel it, if you put T4 here, T4 is equal to, if you cross multiply T4 equal to T1 into P4 by P1. All other data are known data. You can calculate the value of P4 easily. So T4 is known. Now let us take T3 process 3 to 4 because we are coming the other way around. After 2, we went directly to 4, then 1, and then we came back. Because 3 to 4, you can see that now you can apply. 3 to 4 is because you have calculated the value of T4. Otherwise, the T4 is earlier unknown. Now you have calculated the value of T4. Now you can put it T3 by T4 equal to V4 by V3. V4 by V3 is given as 5 expansion ratio. So you can calculate T3. So now you know all the values T1, T2, T3 and T4. Once all the temperatures are known, then it is just writing. So for example, heat addition, it's a constant pressure process. Always remember it is CP. Be careful about it. Because it is constant pressure process. High temperature minus low temperature, T3 minus T2, you will get the heat addition. When it comes to heat rejection, again you can see heat rejection is 4 to 1. But here you note it down, it is CV because it is constant volume. High temperature minus low temperature, 4 minus 1, T4 minus T1. You have to put CV here and you have to put CP here. Be careful about all these things. Once you calculate Q1 minus Q2, efficiency is output by input, work net by heat input. So it is Q1 minus Q2 by Q1, then it is efficiency. That's all. One more problem. Shall we do it? Yeah. This is dual cycle. But dual cycle is otherwise also, it's a closer approximation, so it is called as a diesel cycle. Okay. So here you can see that what are the data given. They had given swept volume, pi before d square. So it is first data is given as, of course, it is a dual cycle, swept volume. Swept volume is V1 minus V2 because process is starting from 1 to 2 is swept volume. Piston moves from BDC to TDC. V1 minus V2, which is given data. Then the clearance volume. What is clearance volume? Clearance volume, you know that it is a volume left behind this volume. This volume is, you know that this volume is V2 and which is equal to V3. So clearance volume is given, that is V2, which is equal to V3, and that is given. Then they have given the third data, which is given as maximum pressure. And you know that maximum pressure is P3, which is equal to P4. So they have given two data. Maximum pressure means it is P3, which is equal to P4, which is given as 65 bar into 10 to the power of 2 will give it in kilonewton per meter square. That will give it in kilonewton per meter square. And again, you can see that fuel injection ends at, again it is a volume of fuel injection. You have to be very careful in this data. Volume of fuel injection is, fuel injection starts and ends is V4 minus V3. Injection volume is V4 minus V3, which is given as 5% of stroke. So 5% of stroke is, I think this is wrong, that is 0.05. Just correct it please. So this is wrong, 0.5 by 100, so 0.05 VS, 0.05 VS. So that is a injection volume. Okay. Then they are given at the start of compression, that is T1, and they have given P1. Those two values are given. Okay. This has been asked in university exams twice, so you have to be familiar with these things. Okay. Initial pressure is 0.9, so it is into 10 to the power of 2, 90 kilonewton per meter square. So volume is given, clearance volume is given. So let us try to make some solutions. What is volume V1? I think volume V1 is, you know that this is swept volume. This portion is swept volume. This is Vs. And this is Vc, clearance volume. So it is the addition of Vc plus Vs. Vs plus Vc will give the initial volume. V1 you can find out. V2 is nothing but the clearance volume. You see, V2 is nothing but the clearance volume, which is again given. So V1 by V2 is compression ratio. So you can calculate the value of compression ratio RK. Compression ratio is V1 by V2, which is 16.14, that you can easily found out. Then once the compression ratio is known, let us move on. You can calculate V4. Now you see V4. What is V4? V4 is, you can add these two things. V4 minus V3 is given because it is a 5% of cutoff is 5% of stroke volume. That is a given data. If you add it with V3, then you will get V4. That is how we can calculate the V4. Once that is known, cutoff ratio can be calculated. That is V4 by V3, that you can calculate the cutoff ratio. Compression ratio has been found, then cutoff ratio has been found. Now let us try to find out all the temperatures. You see 1 to 2 is reversible adiabatic, T2 by T1. Then here I think you know the compression ratio. V1 minus V2 is 16.14. Then just apply, you will get T2. Then you can calculate the P2 value, pressure at point 2, because P1 is given. Here PV equal PV to the power gamma is equal to constant. Once you apply, again V1 by V2 is 16.14. Then you can calculate the pressure. Sorry, this is kilopascal. Okay, this is kilopascal. Okay, this is kilopascal per kilonewton per meter square, kilonewton per meter square. Okay. Okay, then you can once you have calculated all the P2 and other things, let us move to process 2 to 3. We take 2 to 3, V2 equal to V3, then you can calculate the value of P3 straight away. If P3 is found, then use this equation. P3 is given data. They have given the maximum pressure, which is equal to P4 also. So once the given data is applied, I think you can calculate the value of T3. It has already been found out, and T3 now you can calculate it. Then I think you can move on to process 3 to 4. 3 to 4 you can apply P3 equal to P4, that you can cancel it. Then you can calculate the value of T4. T4, straight away T4. I think one more left is T5, isn't it? T5 is 5 to 4 you can take, or 4 to 5. That is a reversible adiabatic process. V4 by V5. V4 by V5 is, I think you see that V5 is equal to V1. V5 is equal to V1. And V4 we have already calculated. Here you have V4 we have already calculated. So V1 is already, we know, PV equal to MRT. That is V1 also we have calculated here. That is stroke volume plus clearance volume. So it is V4 by V1 instead of V5, you can put it as V1. By that you can calculate T5. So once all the temperature is known, that becomes very simple. Once all the temperature 1 is given, you have calculated 2, 3, 4 and 5 one by one. Then heat addition is, here you have to be a little careful. Heat addition is, you have constant volume plus constant pressure. 2 to 3 is constant volume, this is constant pressure. You're careful about CV and CP. CP is 1.015 and CV is 0.718. Then you'll get an answer. And heat rejection is, it's constant volume. So you have to be careful with CV, 5 to 1, maximum temperature minus the minimum temperature, highest minus the lowest temperature in that process. So it is 5 to 1. So you can calculate the Q2. Once Q1 and Q2 is known, efficiency is work net by heat input, okay, not out, heat input. So it is Q1 minus Q2 by Q1, so it is 63.75%. Hope you have understood all the 4 problems. Revise it, look at your notes, then some university question papers, you just go through it and you can do it. Remember this diagram, it's very important. This is the basic to take the given data and other things. Have a nice time, enjoy, break, study, be a student. God will bless you. You will succeed in life. Thank you. Next, video. I'll post it on a review of vapor power cycle, Rankine, reheat and regenerative. God bless you. Thank you for listening.